Welcome to Fairfax Water Laboratory. Fairfax Water maintains a water quality laboratory located at 1295 Fred Morin Road in Herndon, Virginia. It's a sophisticated, well-equipped, state-of-the-art drinking water laboratory that is equipped to handle organics, inorganics, metals, and microbiological analysis. I'd like to take you on a small tour of the lab. Welcome to the Fairfax Water Laboratory. As you enter, you'll be entering into this reception area that has on its right conference room, and then on the left, on the wall here, some information about why we treat water. On the wall to the right, you'll notice that there's a placard of Fairfax Water that describes the commissioning of this building in 2005. And to the left, there are some instruments that are from ages past: microscope, wooden water pipe, a balance, and a surveyor's scope. So now let's go into the laboratory and take a look at the various sections that we have to offer. We are now standing in the hallway in front of the laboratories, and you'll see on the wall the signs that indicate the organics laboratory, metals laboratory, inorganics laboratory, and the microbiology laboratory. Now that we're in the laboratory, I'd like to suggest that we pretend that we're a sample and go to where we would enter the laboratory as a sample and walk through the laboratory as if we were to be analyzed. Now that we are pretending to be a sample, we're entering into the field services area where you would be entered into the laboratory information management system and queued up for analysis in the laboratory. We have 5 staff working in the field services area that are on a daily basis out in the field collecting samples, placing them in clean containers and bringing them back to the laboratory for testing. So once they've arrived at the laboratory, they'll sit at their workstations and enter the information on the sample, when it was collected, who it was collected by, where it was collected, and what tests are required for the sample. Be entered at their workstations into the laboratory information management system and then placed in a refrigerator for storage. So if you're a sample, you want to be placed in a nice clean container, because when you're tested, you want to be tested for what's in you and not what's in the bottle. So we want to have a clean container, which we have dishwashers and laboratory staff continuously cleaning sample containers to make sure that samples are placed in clean containers. We're now entering the microbiology laboratory. If you were a sample, you would look something like this as you enter the laboratory. And this is the area where we perform our microbiological analysis for microbes. And as you can see, we're now in the process of setting up a set of samples to test for total coliform under the total coliform rule. We're now entering the inorganics laboratory, and as a sample, we would look something like this. In this laboratory, we do inorganic testing of water samples, looking for nutrients, things like nitrate, nitrite, phosphorus. We have an ion chromatograph. We have UV-vis spectrophotometers. We have ovens for doing solids analysis, and a variety of other equipment for doing titrometric tests and various different wet chemistry tests. We also have a variety of sensors for conductivity, fluoride, ammonia. So there are a number of tests that we can perform in this laboratory just to make sure that the water quality is what it should be. We are now entering the metals laboratory, and if you were a sample, you would look something like this. So the laboratory is equipped with 2 sophisticated analytical instruments, inductively coupled argon plasma units. The one on your right here is an inductively coupled argon plasma emission spectrometer. And on your left here is an inductively coupled plasma with a mass spectrometer. These instruments are used for metals analysis for regulatory purposes of metals such as lead, copper, mercury, arsenic, selenium, barium, cobalt, you name it, any kind of metal pretty much. And here we have an ion chromatograph that is used for perchlorate analysis. We are now entering the organics laboratory. As an organic sample, you might enter as a 1 liter bottle, or a 40 ml glass vial, or a 60 ml glass vial of amber glass. The analysis in this laboratory is primarily conducted on gas chromatographs. So as you enter, on the left-hand side, there are 2 gas chromatograph mass spectrometers that are equipped to analyze volatile organic chemicals such as benzene or toluene, gasoline, or semi-volatiles such as chlorobenzene or phenanthrene or mineral oil, fuel oils. A little farther down, we have gas chromatographs that are equipped with electron capture detectors, which is a specific type of detector that's used for detecting halogens. Specifically, our interest is chlorine. We're looking at disinfection byproducts called haloacetic acids. So this is a gas chromatograph electron capture unit that's used for that analysis. A little farther down, we have some specialized equipment that's used for emergency response. We have 2 portable gas chromatograph mass spectrometers that are equipped to take out in the field and analyze for volatile organic chemicals such as gasoline or diesel fuel oil that might be released or spilled. And then we have a total organic carbon analyzer that's used for determining the organic content of the water that's coming into the plants. And with that, that's the laboratory tour. Welcome to Fairfax Water Quality Laboratory, and thank you for watching.